Hi, you reached the polymorphism section of Learn Programming in Java course. Okay, once again, I'm Hugo Scavino. A little bit of self-promotion here. Been doing this for 30 years. I started doing Java since the beta, so it's been a long time. I primarily used what I needed to use to get my job done. I've been doing this a while, basically. If you want to know more about me, check out the link to my LinkedIn page and connect with me. Okay, what's required? Really, you just need JDK 8. Now, I know most of you you're running 11, 17, 21, and might be a little bit confusing, but this course really focuses on the fundamentals. The fundamentals are all in Java 8. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. Hey, we don't have a lot of money, so I'm going to recommend some, I think, the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, and programming, his style, his wording. It really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. Okay, what are we talking about? Probably one of the more complex parts of the language. It's called polymorphism. So let's take an example. It's hard to do a real world example since there's so many of you with different real worlds. But let's take the idea of a vehicle. You want to start the vehicle. Now, a vehicle could be a car, or a bike, or a truck. Or it can be anything you want, but you want to start it. Okay, now each one does that differently, but they're still all vehicles. So polymorphism works similarly, okay, by enabling a common action, for example, let's say start, and let's let it be implemented in different specific ways. So let's use that as our example, and we'll see that we want to get code reusability with that. We'll be able to use the same code, the same interfaces, without having to recreate it 3 different ways, 4 different ways. It's going to be more extensible. That means we can add more new classes later, and less code will change. The behavior will be dynamic. That means at runtime, depending on what vehicle you have, you're going to start differently. So that's kind of complex. Let's use a real example here and see if we can get through the subject. Okay, let's be a little more specific on the polymorphism part. It's one of the key principles of OO programming. It's fundamental to the language and to kind of the concept of OO programming. There are 2 types. We're going to focus mostly on the first one, which is compile time polymorphism, and then focus almost exclusively on runtime polymorphism on these slides. They're both important, but compile time polymorphism is method overloading. Okay, is when you can have multiple methods in the same class with the same name but different parameter list. So it's a different interface. So you can have a start method that takes in some parameters, another start method that takes no parameters, but basically you're overloading the method. Now that's kind of cool, but the one I really want to focus on is runtime polymorphism. That is method overriding. That's achieved through method overriding where a subclass, all right, parent-child, provides a specific implementation for a method already defined in the superclass. So depending on the class at runtime, you will get a different implementation, and we'll see more about that. Okay, let's take a look at this code base. We have a car and a truck. They each start in their own way. I don't see them as being related, but they both start. And I have a code base that has a start method in a car, and I have a truck class that also has a start method, and they're 2 separate classes. So let's start with that, where I'm looking at my design and I see that a car has a start and a truck has a start. Could I do something better with that? All right, we have the code here. We have a clunky driver. Haha. We instantiate both a car and a truck. Okay, they're both separate classes. And then when we want to and drive the car and the truck. We have an object for car, and we call the start on that car. Then we have an instance of truck, and we call the start on that truck. Okay, and look at my little method there. It's taking in specifically a car and a truck. This compiled, this works. Maybe this works fine in your world. There's only 2 of these things. I don't really need to be add more design to this. It just kind of works. But then again, is it better? What happens when I want to have reuse? What happens when I want to add, I don't know, more vehicles? What should I do? Okay, I want you to hold on here. There's going to be a couple really important concepts I want you to think about. First is kind of the tried and true hierarchy. Instead of having a car or a truck, I could have a parent class called vehicle. Now, nowhere in the highway is there something that is just a vehicle. There's always cars and trucks. But vehicle is kind of a base. It's something that we all understand exists, but we need an implementation. So we can have that as a parent. It could be abstract or it could be a concrete class. Most likely it's an abstract class. We don't have it as abstract here because I didn't want to introduce that yet. But let's think of that. A polymorphic car and a polymorphic truck, they both have a start method that is inherited from their parent, which is a vehicle. Now, I want to take that one step further. You've seen this before with things like animal and bear and a cat. But what if the vehicle was the one that implemented the startable interface? Okay? Could I have the parent class implement, I don't know, a default startable? Sure. And then could my children override that? Sure. We can do that too. We could also have the vehicle not have a start. So that's possible too. But this is kind of a moderate, not a complex scenario where you have a parent class in having some methods, perhaps even implementing some methods from another interface, and me as a child, I will extend the parent class, which comes along with the startable interface. So I get 2 things. I'm showing you 2 things at the same time. And the reason I'm doing that is because it's really kind of a common design, where I, as a child, will inherit from a parent, and the parent is the one that is responsible for implementing the startable. Why the parent, and why can't each one also implement startable? Well, why? Why should each one? It can share that with the vehicle. That way I don't have to force the car to be startable and the truck to be startable. I can have that in my parent class, and that relationship is inherited as well. Think about that for a little while. This is a common design. Remember, there's no multiple inheritance in Java, but I can have interfaces. So the interfaces can be implemented and maybe better implemented by my parent class rather than each one of me implementing the interface. So I'm both a vehicle and I also implement startable through vehicle. Now we have an updated start vehicles. These are not minor code changes. This is a big deal. Okay? Look, I am creating a new vehicle that's implemented as a poly car. I have another vehicle, and that variable name is called truck, which is implemented as a polymorphic truck. So on the left-hand side, I have the base type. I have vehicles. On the right-hand side, I have the implementation. Think that through. I am dealing, and I prefer to deal with interfaces, not implementations. But I need an implementation. The same way a vehicle needs an implementation to be alive. A vehicle with a variable car needs a polymorphic car to be instantiated. I cannot instantiate a vehicle by itself. I need it to be implemented with something concrete. Here it's a car and a poly car and a poly truck. Now, I can put those 2 objects in an array of vehicles, right? I can deal with these objects by their interface. Why would I want to do that? Take a look at, and this is what my favorite part about OO programming is. Look at how I'm defining my interface, not based on a car or a truck, but based on an array of vehicles. And then I can loop through my vehicles and do whatever I want with them, call whatever common method they have, and in this case, it's start. Is the code that much different? Line per line, not that much different, but design-wise, this is a significant difference. I am dealing with interfaces, and I'm instantiating them with implementations, but my interface is with the interface. It is with a parent class vehicle. It is not with a car and a truck anymore. I'm just abstractly dealing with vehicles, and this gives me a lot more robustness, reusability, and ability to change, have a lot less code changes in the future when I have changes in my code. So your question might have been, that was a lot of work. Didn't see a lot of value in it. But what happens, and this will happen in the business world, I get a new type of vehicle. So I no longer am selling cars and trucks, but now I'm expanding my business because I've been successful and now I'm selling boats. Well, how does that change things? If you have the second design, where you're dealing with interfaces, a boat is a vehicle, boats also start. I can add a boat to my array of vehicles. And looky here, this code, the code that deals with starting vehicles, has always been dealing with the interface, always been dealing with the parent class vehicle. It's still calling start. The for loop does not change. So your code doesn't change because I was focused on the parent class. I was focused on the interface, not the implementation. Now, when I say interface, I could be talking about the parent class or the interface that's actually implemented. When I'm saying interface, I'm talking at the OO level, not at the Java level. But this is what I mean by programming at the interface, not programming based on implementations. My code is robust. I don't have to make changes to it. I just have to make this one change at adding a boat or another type of vehicle to my array, and this code over here stays the same. For any of you who have been in the C++ world, you're probably wondering what happened to multiple inheritance. We don't do that. It causes more problems than it's worth, but Java does allow you to implement as many interfaces as you need. So I don't think it's a limitation. It's just I think the better way to have those kind of relationships. You're really only one thing. I am a mammal. So if I have single inheritance, it begs the question, how are things initialized? They happen from the top to the bottom. The base class or classes initialize themselves. The child classes can pass it a constructed value up the chain with a special keyword called super, but you don't have to. All right. But that if you do call your parent with super, it has to be the first line in the constructor. Okay, not counting comments. Okay, so inheritance initialization is basically top to bottom. All right, so I have big truck extends polytruck extends vehicle, and vehicle is the top parent, and it has a number of wheels, and it also has a relationship to an engine. So what does that mean? That means this gets initialized first, then the engine gets created, whatever the engine needs to do, and then I do what I do in my vehicle constructor. After that, the polytruck goes next. It does what it needs to do. Finally, the big truck calls or does what it needs to do in its constructor. So basically, top to bottom. Now, vehicle and polytruck could have more methods and more classes inside of it too. But basically, from top to bottom, that's how it's initialized. Your constructors really should be careful about assuming what's initialized and in what order. Be careful of handling that, but you need to know that your top gets initialized first, and your constructors really should do the least amount of possible to construct themselves, and be careful of referring to variables that have not yet been initialized. So what are the best practices here? All right, you want to minimize the steps that are needed to put you in a valid state. Okay, you do not want to call other methods from your constructor. That's just going to be chaos, madness, and things just won't instantiate right. Lots of bugs there. So the only methods that you can feel safe in calling from a constructor are static methods. All right. So be careful in what you do in the constructor. So each one of these is a constructor. All right. And the constructor calls its parent, and this constructor calls its parent. Notice that they're not calling other methods. And if they had to be final. But you really want to minimize the work that's happening in these constructors. What's the least amount you have to do to be in a valid state? That's the goal. So this OO stuff has been great. We love it. I don't need a no implementation. I can deal with vehicles. And my interfaces are always set up at the interface level. I'm not creating methods that talk about cars and trucks. Instead, I'm creating methods that deal with vehicles. What if I do need to know what type you are? All right. If you're a truck, I need you to also turn on the refrigerator. If you're a boat, I also need you to lift the anchor. We try to avoid this. We don't want to make a whole lot of complicated if statements, and we don't like that. And generally, if the start methods are so different, then maybe they're not vehicles. All right, maybe boats don't inherit from vehicles. Maybe boats inherit from something else. Cars and trucks maybe stay the same. But if there's a little bit that we need to do, we can downcast. And let's see examples of how to do that, where we treat the interface differently based on what type it is, but we need to know what type you are before we treat you differently. Okay, so here's the code. Remember that for loop I had before? I am so proud of our vehicle interface over here. I needed an array of vehicles. I'm so happy with that. I have a for loop that looks through the array and gets me a vehicle, and look at me. I am calling start on all the vehicles. I don't care what kind of vehicle I was. I'm a boat, I'm a car, I'm a truck, but when I start my truck, it needs to drop its cargo. Okay, so it needs to do something different because it's a truck. I don't like doing this code. It's maybe a code smell, but if you need a downcast and you need to know who or what type you have, when before all you had was the interface, Java will know what it is at runtime. I'm not going to know at compile time. All right, but here you can use the very popular instance of. So if you take the object and ask it, are you an instance of a poly truck? And by the way, this is a little shorthand to get you the variable. Then you can call a specific truck method. So cargo only belongs to truck. So if I'm a type truck, a polymorphic truck, then I can call this little method. So this works. All right. Yes, it's kind of a wart, but you can downcast to know exactly what kind of type you have. You don't want to do it, you don't like doing it, but if you have to, you can. Now, some of you from other languages like C or C++ may be annoyed by the instance of. That seems like a lot of work. Can't I just cast the class? I know it's a truck. Trust me, I know what I'm doing. So yes, you can do this in Java as well. You can cast an object into another type and cross your fingers and hope it works. What if it doesn't? What if this vehicle is a car or a boat? Well, you're going to get a class cast exception. So that's why we like the instance of, because it's an if check. All right, this is not going to crash at runtime, and if it's not a polymorphic truck, it's just going to move on. If you do this kind of code where you force something from one type to the other type, you're most likely at some point going to run into a runtime exception, and we want to avoid that. Okay, to summarize, we love polymorphism. One way to get polymorphism is through inheritance. We saw that in big truck is a vehicle. We also added the ability for vehicles or any parent actually to implement interfaces, which is not inheritance. That is just good old-fashioned interfaces. We can accomplish polymorphism by combining the two. But specifically in the example we were using inheritance, and that is an is a relationship. That is an is a relationship. So, in summary, polymorphism means many bodies in Latin. Maybe you didn't know that, you do now. It works within the concept of inheritance and interfaces. The start method, if you remember, was the only method we needed as a vehicle, and we thought we were really cool. And that's what I want you to get out of this, is that if you design your hierarchy and your classes correctly, you don't need a lot of clunky code. You can have a layer abstraction. You can talk in terms of vehicles, not cars and trucks. And then when things change, when you add boats, you don't have to change all your code. So polymorphism, the syntax, I don't really want to worry you too much about it. You'll get it. But what's most important is that you understand the concept of it, that it allows us to be extensible. It does a code reuse, and it is one of the fundamental pillars to OO programming. Thanks.